예, 대답이 없으면
네.
잘 들리는 걸로 알겠습니다. 자, 강의 시작하도록 하겠습니다. This is the second week, and we are going to start with introduction to environmental statistics. So today's topic includes the background information, which we are going to talk about some of the basic concepts of the statistics and environmental statistics. And then we are also going to talk about the aspect of the environmental problems and the role of the statistics. And then we are going to move on to talk about a brief review on statistics. I'm not so sure if I can cover all of these issues today, so probably I can cover up to the second topic, and then I'll probably do something with the third topic. But depending on the time, I'll just adjust the progress. Just make sure that you can understand everything about this topic, because statistics, just like the other topics, if you lose something, then you'll never be able to catch up with the remaining part of the lecture. So you have to start from the beginning, and you needed to have the fundamental concept, because everything's are just connected. So let me just read the background. I just briefly mentioned last week about the statistics, and statistics is actually a technique and the kind of this method to get information from data. So statistics, people say that this is a science of data, because every time when you try to consider or try to apply statistics, you have to start with some data. So data may be the numbers or the characters or some information, some facts. There are many different types of the data, and statistics is the way that we can get some meaningful summary or some meaningful idea from this data. So statistics is actually a way from data to information. You may think that this data and information are identical. However, when it comes to the statistics, two things are totally different. Data is like raw materials, like the raw materials for cooking, and information is the final food, like Korean food, Japanese food, or Western food. So information is kind of the things that we have a certain structure of the data. So in this context, statistics is very important. So in other words, statistics is a tool for creating an understanding from a set of numbers or text or some other forms of the data. In most cases, especially in engineering the field, we deal with the numbers. However, statistics is not confined to the techniques for dealing with the numbers. It can be used for text mining or text analysis, or it can be used for other qualitative data. So in fact, there are a lot of different ideas and variations that we can apply the statistics. So for example, if we have a certain numbers, the numbers themselves may not have any important meanings, but when they go through the statistics, it can be information. So the information that we can have is like this: the average or variations and distributions, probabilities, and there are a lot of things that we can extract from this data. And so again, this is why we have to learn about the statistics, because we needed to deal with the data, and data is not perfect, and it's not sufficient for us to get enough knowledge or enough information, and that's why we needed to apply the statistics. Statistics is concerned with the scientific method for collecting, summarizing, presenting, and analyzing the sample data, as well as drawing valid conclusions about the population characteristics. So in fact, later I'll talk a little bit more about that, but there are two types of these statistical techniques that we have to learn. The first one is about the summarization, presentation, the analysis. The second one is for collection and drawing conclusions, or some other aspect of the statistics. So depending on our purpose of the application of the statistics, we needed to apply different techniques. So in other words, statistics can do a lot of things if we know well about that. Statistics is essentially a branch of applied mathematics. So if you don't know anything about the mathematics, you may not be able to understand the statistics. Fortunately, the mathematical techniques and knowledge required for learning the statistics is not very high, because we just have to stick with the elementary calculations, as well as some computational calculations. And as for the computation, instead of using our hands for getting the numbers, we can use the computer softwares like the statistical analysis software, and they can do the things instead of us, so that we can easily apply that softwares for the statistical analysis. So although we still needed to know about the mathematics, but we can still easily understand with relatively weak background on the mathematics. So it's not like, the integration and differentiation and the solution of very complex partial differential equations or something like that. Statistics is, in terms of the mathematics, is not really very challenging. So we are not going to learn about the statistics itself. Instead, we are going to focus on the environmental statistics. Although we started looking at the environmental statistics last week, I just want to review this concept again, so that you can have the proper starting point for learning this course. So what is the environmental statistics? Environmental statistics is the application of statistical method to environmental science. So we have a special situation related to the environmental science and engineering. Depending on that situations, the techniques and the method should be different. And with that reflection, we can modify the statistical techniques, and that's the environmental statistics. So later in today's lecture, we are going to see the difference between the commonly used statistical techniques and the situation that we face with the in terms in the field of this environmental science and engineering. So environmental statistics covers procedures for dealing with the questions concerning the natural environment in its undisturbed state and the interaction of humanity with the environment and the urban environment. So in fact, there are two different situations: the nature and environment and the artificial cases. So later, the focus is on the relationship between the human activities and the environmental interactions, environmental reactions. The field of environmental statistics has seen rapidly grow in the field in the past few decades as a response to increasing concern over the environment in public, the organizational and governmental sectors. So environmental engineering becomes more and more important because people have witnessed some serious environmental pollutions as well as some of the crisis that may come from the environmental problems. So because of that, we needed to have the techniques for understanding these environmental systems, and environmental statistics is the way that allow us to do that. And that's why many people are more and more interested in the environmental statistics. So where can we use the environmental statistics? There are a lot of different ways that we can use these environmental statistics. So the use of environmental statistics is not just limited with the examples that is shown on this slide. Statistical analysis can be used for environmental sciences because it can let the researchers to gain an understanding of the environmental issues through researching and developing potential solutions to the issues they study. So whenever we want to learn about the environmental systems, or environmental science, we needed to have the actions or experiments. And every time we do that, when we do that, we needed to have a proper background, which is the statistical analysis, because there are a lot of variations that we have to consider in the environmental systems, and a systematic way that we can consider is, of course, the environmental the analysis techniques. So the application of environmental method to environmental science are numerous and varied depending on the situation. So for example, if you want to know something about the natural river and its water quality, or if you want to know about the efficiency of wastewater treatment plant, the techniques that we have to apply may be different in two cases. In fact, there are many other situations that we may need to consider in the case of the environmental science and engineering. And depending on the situation, every time we need to have a different method optimized for that problem. So this is why we needed to learn about the principles of the environmental statistics. And at the same time, we needed to have typical techniques and protocols that we can apply for some typical problems that we may encounter in the environmental engineering, the applications. So typical situations that we may have to consider is the things related to the Health and Safety Organization, Research Institute, and water authorities, and laboratories and agencies. And in every different places, in every different fields, their concerns may be different. So we need to consider different kind of techniques for that problems. So sometimes our target may be the pollution control or regulation or prediction or the other things. Again, we needed to have some variations. So environmental statistics is especially pertinent and widely used in the academic, governmental, regulatory, technological, and consulting industries. In fact, they are like all the places that they needed to deal with the environmental problems. So in other words, environmental statistics is required in every different field related to the environmental engineering and environmental science. So there are some examples of the specific applications. For example, risk analysis or environmental policy making and sampling planning and environmental forensics. These are some of the examples that statistics can be very useful. As I already briefly mentioned, in fact, there are two types of the statistical techniques that we first have to understand. This is not just for the environmental statistics. In every statistics, there are two main categories. The first one is the descriptive statistics. It is not used to make inference about the data, and it can be just used to describe the characteristics of the data. So it's just for describing the data, and that's the first category of the environmental statistics. The second one is the inferential statistics. It is actually used to make inference about the data, test hypothesis, and make predictions. So in the second category, if you want to know about the environmental systems or natural environment, we first needed to have some hypothesis, and by doing some experiments and by analyzing the data from that experiment, we can either confirm that the hypothesis is correct or incorrect. And that kind of step is the the basis for every inference required for the environmental, for the analysis. And these procedures are called the inferential statistics. In fact, as for the study, there are several different types of the study that is covered in the environmental statistics. The first one is the baseline study, which is required to document the present state of an environment. So, for example, if you want to know about the pollutant concentration in a river, we needed to carry out the baseline study to see the current state of the environment. The second type of the study is the targeted study, which is required to describe the likely impact of the changes being planned or of accidental occurrences. So if we build a factory near the river, and if we have some wastewater discharge to the river, in that case, the pollutant concentration will change because of that wastewater discharge, and that can be just analyzed by doing this kind of the targeted study. So in that case, we can again have the hypothesis, and we can analyze the data, and we can see whether this impact is significant or insignificant. The third one is the regular monitoring to attempt to detect changes in the environment. So for example, if we built the factory, and if this factory releases some of the treated effluent, and if you want to know about the concentration of the pollutant in this effluent, in this case, we regularly get the samples from the effluent, and we needed to analyze this sample. So in that case, we can monitor whether this pollutant concentration is fairly high or fairly low, and that kind of action can be classified as regular monitoring. In this case, we are trying to detect the changes in the environment. For example, in some day, if the pollutant concentration increases significantly, that can be detected by having this regular monitoring. And this data can be used for this targeted study to see whether this change can actually affect the pollutant concentration in that river. So as I already mentioned, data is very important, and then we have to know what kinds of data that we have to deal with. So we need to know about the sources of the data required for the environmental statistics. So there are different types of the sources that can be used for environmental statistics. For example, surveys related to human populations and environments can be one of the examples of the source of the data used for environmental statistics. Records from agencies managing environmental resources, maps and images, equipment used to examine the environment. For example, online water quality measurement online water quality measurement device can actually generate the data, and that can be also used for the as the source for the environmental statistical analysis, and the result from the research can be also used for the as the environmental data. So again, this is just an example. There are a lot of different data that we have to deal with when we consider the application of the environmental statistics. So from now on, we are actually going to study some of the details on the environmental statistics, because the things that I briefly explained here is just a brief background, and we needed to actually learn about some of the details. Anyway, a primary component of the data is direct observation, although most environmental statistics use a variety of sources. And we actually needed to apply some of the typical method of the environmental statistics. In fact, environmental data is very special compared with the other types of the data. For example, the data from a factory having a manufacturing process, or environmental data. For example, data from a factory is well defined, and it has a certain rules, and it can be controlled by the human operators. However, for example, on the natural environmental system like rivers or lakes, and in that cases, people cannot adjust the conditions easily, and there are some unexpected changes that we may have every time we collect the data. And there are a lot of variations and deviations and changes in the data. So because of that, we needed to have some of the techniques to deal with that kind of environmental data. While there is a basis for the method used in other fields, many of the techniques used in other fields should be adapted to be able to deal with the data, environmental data. So again, we need to overcome the limitations of the environmental data by adapting and adjusting the techniques used for the environmental statistics. So in fact, some of the typical techniques that we commonly use for dealing with the environmental data is, for example, linear regression, generalized linear models, and nonlinear models. They are, again, just like examples. And in addition to those techniques, there are many other methods of the environmental statistical analysis, and but again, we need to have a special situation, and that can be explained in the main part of the this lecture. Okay, with that background information, let's move on to talk about some of the details of the environmental problems and the statistics. So in order to apply some statistical method for analyzing the environmental data, we first have to understand the situations that we have in the environmental problems. In fact, there are many different aspects of the environmental problems, because environmental problems is not just related to some scientific and technological aspect. Instead, it can have social aspect, political aspect, or psychological aspect, and some medical aspect. So, of course, in our situation, we may not need to consider all these issues and all these aspects every time we deal with the environmental problems. But anyway, we have to know that these environmental problems are not very simple. So this is a very complex problems, and understanding and solving such problems requires a very complex the acquisitions and the analysis of the data. So treating these quantitative problems effectively involves the use of statistics. Again, this is why we needed to apply the statistics for solving the environmental problems. If this problem is simple, we may not need to apply the statistical method. If the data is well defined and the size of the data, the volume of the data is not very large, in that case, we may not need to apply the statistical method. However, in most environmental problems, we have to deal with a lot of data, and the problems are very complex, and this is why we needed to use the statistics. Statistics can be viewed as the prescription for making the quantitative learning process effective. So it's like the process that we are getting to know about the environmental systems and the situations related to the environmental problems. So we have to do step by step for getting more information from the data, and by testing the hypothesis one by one, we can now eventually understand what's going on here and how can we solve such kind of problems. So how will using statistics help solve the environmental problem, and which techniques should be used? So many different problems arise, and many different statistical techniques exist, ranging from making simple plots of the data to iterative model building and parameter estimation. So for example, if you have data and if you just have a plot, this is just one of the statistical techniques that we apply for the analyzing the environmental data. Or we can have very complex model for predicting the behaviors of the environmental system, or we can have the hypothesis testing for the parameter estimations. So there are a lot of different techniques that we may consider for this case. And since we have a lot of selections, possibilities, we needed to know what is required for these specific problems. Some problems can be solved by subjecting the available data to a particular analytical method. So doing statistics can be like the coaxing stubborn animals. So for example, in rodeo, the cowboys wanna just ride very wild bulls or wild horses, and in that case, the cowboys, just they cannot succeed from the first time. They try until this animal can accept this cowboy. Statistical the analysis is similar. We have to do several things, try, and some of the trials may be successful and some of the trials may be failed. But anyway, by keep doing that, we can learn more about the environmental problems, and that can lead us to have the final solutions. So we have to do, we have to try several times, and we have to have a stepwise learning process for dealing with that kind of problems. Sometimes small steps, often separated by intervals of frustrations, are the only way to progress at all. For example, if you have a certain target, for example, if we have a lake and we don't know anything about the types of the pollutant and the concentration of the pollutant in this lake, and if you want to start analyzing this, we first have to make a hypothesis that this lake has a certain types of the pollutant, and maybe it is not included in that lake. So this is a frustrated failure from the first trial. But if you just do that several times, of course, somehow you'll identify the type of pollutant, and then you will actually learn about the ranges of the pollutant concentration in that case. So finally, you'll actually have more detailed information about the types and the concentrations of the pollutant in this lake. So again, we need to have several steps to learn more about the environmental systems, and that's probably the only way for us to solve these environmental problems. Even when the data contains the bountiful information, it may be discovered in bits and at intervals. So the goal of statistics is to make this discovery process efficient. So sometimes without the statistical techniques, we may need to test the we may need to measure the concentration of the pollutant 1,000 times without statistics. But later we'll see that statistics can actually reduce the required number of experiments. So instead of having 1,000 experiments, we can have only like 100 experiments with after applying the statistical method. In this case, we can reduce almost 90% of the measurement, so that we can save a lot of data, we can save a lot of money, we can save a lot of time, we can save a lot of manpower. So that's more efficient. So statistics in this context is very useful because it can make the learning process more efficient. Skills and talent help, experience counts, and the tools are necessary. So for example, for having a very good analysis with the statistical method, we may need to have a very good software. And if this is very convenient, the analysis steps may be also very efficient. environmental laws and regulations are about the so environmental regulations and statistics are closely related, because if you want to have a regulation, once you have a certain regulation, for example, if you want to set the regulation for the mercury less than 0.1 microgram per liter, in that case, this is a regulation. And this regulation may have impact on economics and health and even politics. There are a lot of impacts caused by this regulation. So we may not know what is the correct answer. And what we need to know is how we can set up this regulation with some reasonable background. However, again, it's very difficult, because if you want to make regulatory guidelines, in that case, you have to consider the toxicity and the relationship between the toxicity and the concentration. And the toxicity is related to the health impact, which varies with people and with the situations. And there are a lot of uncertainties which cannot be properly analyzed. So there are a lot of things that we have to consider. So since the situation is very complex, again, we have to go back to the basic principles. If the situation is very complex, or if the data volume is very large, in that case, we have to consider the application of the statistical method. So again, environmental laws and regulation about these toxic chemicals, water quality, air quality, there are a lot of things, and they should be related to some statistical the situations. So every time when you see the regulations, it actually involves the concept of the statistics. So for example, limit of detection, which is required for every regulatory guidelines, but this is actually the concept of this is actually a statistical concept. And if you have, for example, if you have environmental biology, there are a lot of the terminologies appeared, and again, they are also closely related to the statistical concept. So in summary, if you want to learn about, if you want to understand the environmental regulations, we first have to understand the statistics, because without the idea of the statistics, we may not be properly understand the meaning of the environmental regulations. So this is an example of the Wisconsin law that have the statistical concept appeared in that document. So for example, means, length, and probability, normality, normalization, these all concepts are actually coming from the environmental statistics. So you see that the environmental laws are relying on these statistics. Again, if you look at these EPA guidelines, which is required for the environmental regulations in the United States, again, there are many concepts borrowed from the statistics. So again, without that concept, without that applications, we may not be able to fully follow these guidelines. So in environmental engineering field, environmental science field, statistics is kind of mandatory. And the reason why we needed to apply the statistical concept in the environmental rules and guideline is because there is a burden that uh, actually requires the huge the investment in collecting the environmental data. For example, if you want to know about the current status of the water quality and water pollution in a river, the best way is to measure all these waters in that river. And this is simply impossible. So for example, if you want to know about this concentration of the pollutant in Han River, the way that we have 100% guarantee is to collect all this water and measure the pollutant concentration from all water flowing in this Han River. And we can easily understand that this is simply impossible and this is not required. The practical way is to just have a certain point and get some small portion of the water from that river, and by analyzing these so that we can actually estimate how much the pollutant concentration that we have in this whole Han River. Of course, this is not 100% information, accurate information. Maybe this has the accuracy of 95% because this is not the totality of the data. We just have a small fraction of the data. And 95% or 90% or 80%, that can be calculated by applying this statistical method. Again, what's important here is in most cases, in most situations related to the environmental laws, is that we cannot measure all the data. We can have a large collected the data, environmental data required for these laws and regulations. Instead, we may need to have very small data or the poor data, and we have to deal with that data, and that's the role of the statistics in the environmental rules. Anyway, the cost of poor data is not only the price of collecting the samples and making the laboratory analysis, but is investment wasted on remedies for non-problems and in damages to the environment when real problems are not detected. So it's very important to have good data so that we can have reasonable or good decisions, and that can significantly reduce the waste of money or efforts that is required for dealing with the environmental problems. So again, one way to eliminate these inefficiencies in the environmental measurement system is to learn about these statistics. So again, in this case, the result may be very different if you select this point or this point. And the determination of the points that we need to have a small portion of the water in this situation, that should be determined in terms of the statistical concept. Otherwise, by choosing a certain point for collecting some water, may not be really meaningful or efficient because we need to have the data that has enough quality. So let's think about the decisions a little bit more, because every time we have the analysis, in many cases, our target is to have a decision on some problems. For example, if we have a situation that lake water is polluted, in this case, we may need to have a decision whether we have to clean up the water or we just let this water be there so that the natural purification can make this water quality better. So this is one of the examples of the decision that we may need to make when you have environmental problems. Anyway, intelligent decisions about the quality of our environment, how it should be used, and how it should be protected can be made only when information in suitable form is put before the decision makers. So in this case, whether purify or not, the decision should be based on some scientific information, the evidence. So for example, if the water quality of this lake will become worse in the future, in this case, we needed to purify this water in an artificial way. However, if this water quality will become better in the future, in this case, we may not need to just use some money for purifying this lake water. So that should be determined based on the data collected from this lake, and some other information can be used for having this kind of decision. Of course, if this data is wrong in that case, for example, the actual concentration of the pollutant is 10 milligram per liter, but somehow if the collected data indicates the concentration is 1 milligram per liter, this will lead to the conclusion that we may not need to clarify this water because the pollutant concentration in the current status is too low. But this is clearly a wrong decision because this wrong decision comes from the mistake or errors occurred during the procedures of the collecting the water sample from this lake. So again, this example shows how the data how the data is important, because if we have a wrong data, we'll have a wrong decision, and this will lead to a lot of this will actually waste our money and time and the other efforts. So again, if we want to make these proper decisions, we need to have some facts. We want the truth, and we wanted to have some we wanted to have some inferences about the truth. So by making careful planned measurement and using them properly, our level of knowledge is gradually elevated. So for example, if this measurement is not proper, we can improve these techniques. And so in that case, the actual measured data may be close to the true data, in that case, we can actually have better decisions. So again, the difference between the truth and the measured one can be minimized by applying proper statistical techniques. And again, in this context, statistics is very important. So as I already mentioned, regardless of how carefully experiments are planned and conducted, the data produced will be imperfect and incomplete. And this is not because people are making some mistake. This imperfect data originates from the fact that we are not examining the totality of the data. The imperfections are due to unavoidable random variations in the measurement, because every time we get some sample from the original target, original system, the errors and imperfections are just unavoidable, because that's the actual nature that we have to consider. The data are incomplete because we seldom know, let alone measure, at these influential variables. So, for example, we cannot have the data measured in every second. In practical situations, we may need to measure the concentration of the water in every 2 days, in every days, or in every week, or in every month. So it means that the data is not continuous. It's some of the incomplete data. And for example, sometimes we may miss the data because of the errors of the measurement device, and or because of some other reasons, we may not have the complete data. And that should be also considered, because this is the situation that we always have in environmental applications. So these difficulties and others prevent us from ever observing the truths exactly. So we may not really know the true concentration of the pollutant in a lake because of these limitations. So the relationship between the truth and the inference in science is similar to that between guilty and not guilty in criminal law, because we never know whether this person is guilty or not guilty. We have to make a decision based on some evidences. The statistical inference is also same. We cannot know the truth through concentration or through natures. Instead, we can only make an inference, and we can only test the validity of the inference by examining the data, the information collected from the statistical method. So a verdict is based on the evidence, and if we cannot prove that this person is not guilty, that is regarded as a guilty person. Likewise, the truth of a hypothesis cannot be firmly established. We can only test to see whether the data dispute its likelihood of being truth, because every time we have a certain possibility, and if this possibility is small enough, we can say that this can happen. However, if this possibility is very large, we cannot say that this can really happen. So that's the way that we can make a statistical the inference and hypothesis testing, which we'll actually learn more about later in this course. So if the hypothesis seems plausible, in light of the available data, we must make decisions based on the likelihood of the hypothesis being truth. So again, this is the keywords that actually determine whether this decision can be made in favor of or against the hypothesis. Also, we assess the consequences of judging a truth but unproven hypothesis to be false. So if we don't have evidence, in that case, we have to assume that this hypothesis is false. So again, in this case, the collection of the data, analysis of the data, and testing the hypothesis, and having some inference. And this is the procedures that we can approach the true data in the case of the environmental statistics. Statistics are numerical values that can be calculated from imperfect observations. In this case, this statistics is not the statistical techniques that we are talking about. This is the numbers that is generated from the samples. So, for example, sample mean or sample variations, they are called as statistics. This is confusing, but since people are using that terminology, so we have no choice but to accept the rules. Anyway, a statistic estimates a quantity that we needed to know about but cannot observe directly. So the reason why we have to calculate the statistics is because we needed to know about some unknown values. That cannot be directly calculated. In that case, we can use the statistics. Using statistics should help us move toward the truth. So again, the long story that we have gone through is the journey toward the truth in the uncertain situations. However, it cannot guarantee that we will reach it because truth is just the truth. We never know whether this is really true or not. Instead, we only have the way that we can have the conclusion that is very close to the truth, depending on the situation. But again, we need to accept that, accept the fact that we cannot know the actual truth. So based on these statistical techniques and method, we can set up a learning process. And in this case, an experiment is like a window through which we view nature. So for example, if you have a lake, and if we know about the pollutant concentrations in this lake, and the way that we know about this one is, of course, we needed to carry out an experiment And this experiment is like the window that we can just see through this river, this lake, this information, unknown information. Because without this experiment, there is no way that we can see the unknown values. And since this window is very small, because so that our view is not perfect. So this window only shows what we can see from this small piece. So again, we cannot see the whole picture. We can only have limited information from this experiment. So the observations that we make are distorted because if we have this target, a very good metaphor that I can use is the elephant case. You may know that the story about the examining the elephant and by a blind man, and if there is a blind man and if he tried to figure out what's the elephant, the best way that he can, the only way that he can do is to touch the elephant from one place to the other place. So in this case, if he touches the leg, he may think that this elephant is like a, bar or something, or cylinder or something. And if he touches the elephant's nose, he may have an idea that this elephant is very long or very fat or very heavy. So depending on the place where this blind man touches the elephant, he may have a different idea. And this idea is actually distorted. And just like this situation, when we have an experiment, and if we only have a small portion of the data from the total data, this observation may be distorted. So this information may be misleading. And so we needed to understand the imperfections that are included in this observation. And that is also called noise. So even if you touch the elephant, you may have different just idea. So that is some the annoying parts of the observation, because we wanted to have the accurate information. However, it cannot be done very easily because of a lot of different situations that we have to consider. So the best way that we can do is to minimize the distortions and minimize the noise and make this view as perfect as possible. So one way that we can do is statistically efficient design, which can actually see how we can systematically see the elephant. So in that case, we can minimize the distortions by having a random sampling, and we can also minimize the noise by reducing the variations. So by doing this, we can increase the size and improve the quality of the experimental window. And using this good design, we can actually overcome a lot of limitations. On the other hand, if the design is poor, it will actually make things more blurry. So it's like the situation that we are seeing something through a very blurred window. So again, this statistical design is very important in learning something, especially when the target is unknown. In this case, we probably needed to apply this statistical design and statistical techniques. And in this case, learning process is an iterative process, as I already mentioned, because if you just have one hypothesis and one inference, we cannot know everything. So we first have to have an inference and test the hypothesis, and depending on the result, we needed to have another inference and another hypothesis testing, and then we can also learn more. So just like the situation that we can touch the every parts of the elephant, in that case we can see the whole shape of this elephant. So this learning process is actually same. We can repeat and we can have an iteration process by having a series of inferences. So the hypothesis is usually stated in the form of a mathematical model, and whatever form the hypothesis takes, it must be proved and given every chance to fail as data becomes available. So sometimes the hypothesis may be incorrect if we have new information. So the hypothesis, the result of the hypothesis testing can change every time, depending on the types of data, depending on the data. The hypotheses that are not put to the test are like good intentions that are never implemented. So they remain hypothetical. So it will be easier for you to understand how this learning process goes based on this statistical method. So in this case, our target is to know about the truths of the nature. So we know about the true values, true variables, and true models. And the only way that we can get data from the nature is the experiments. And of course, we needed to have a series of the experiments, not just a single experiment, because this is an iterative process. So in order to do that, we first have to define the problem and make a hypothesis. And based on this hypothesis, to test this hypothesis, we can design experiments and we can implement the experiments. And as a result of the experiments, we'll collect the data and we can analyze the data. And from this data, we can have the final deductions and conclusions. And in the first trial, the problem cannot be fully solved, so that we can go back to have another hypothesis, or we can only repeat the experiment to see whether the data is reproducible. So anyway, we can repeat these steps several times until the problem that we needed to address is solved. So until we get this final targets, we needed to repeat these steps several times. And by doing this, we can have more information on this nature and our targets, and eventually we can learn about these targets. And that's the learning process that we can apply for as an environmental engineer. So I guess it's good enough for us to cover up to this point in the first class. So I guess I can continue in the next week from this point, so that you can have more idea on the environmental statistics, and with that we can actually move on to the next chapter, which is about the fundamental aspect of the statistics. 자, 오늘 수업은 여기까지 하겠습니다. 그리고 오늘 수업은 이제 그 온라인으로 이제 화상 강의로 하고요. 내일 수업은 강의 녹화로 하게 되는데 강의 녹화된 내용은 통계학에 대한 기초적인 내용이 있고요. 마찬가지로 지난주에는 확률에 대한 기초적인 내용을 공부했고, 이번 주에는 통계학에 대한 기초적인 내용을 조금 복습을 해야 아마 주로 이제 강의하는 내용을 따라갈 수 있을 것 같아서, 이번 주까지 이제 동영상 강의에서는 통계학에 대한 내용들을 좀 리뷰하는 시간을 가질 거고요. 다음 주부터는 본격적인 수업 내용과 함께 그 화상 강의랑 동영상 강의를 병행해서 진행하도록 하겠습니다. 자, 오늘 고생 많았습니다.
감사합니다.
네, 수고했어요.